Dear, dear viewers, kindly spend time in going through the solutions before or after assignment submission to get better score in the exam. Please subscribe to our channel because we need your support. Kindly share our channel to your classmates, friends and others for their benefit. Now we will continue with the 8th question. They have given the Boolean expression. We have to implement using a mux 4:1 mux. They have given a function f as a 4 variable. It is a 4 variable function, and this is a pause expression. Pause, indirectly they have given expression. So we will try to solve this problem. So there are 4 variables a, b, c, d. So first what we'll do, a, b, c, d 4 variables are there, and 0 to 15 decimal number. So all input combinations from all 0 to all ones, first write down that one. Okay, then so that is 0 0 0 0 0 0 0 0 1 0 0 1 0 0 0 1 1 0 1 double 0, so on. Okay, then we have to enter f value of f here. What is f1 or 0, that we have to enter. For that we will see the problem here. So what is the problem here? They have given this equation 4 8 9 10 11 14. For all these serial numbers or decimal numbers, the f is 0. So therefore 4 it is 0, 8 f is 0, 9 f is 0, for 10 f is 0, 11 f is 0, then 14 f is 0. Once again we see here 4 8 9 10 11 14. So 4 8 9 10 11 14, all this serial number f is 0 0 0 0 0 and fourth, this is 0. What about the remaining? So for remaining you have to enter once. For remaining you have to enter 1 1 1 1 1 1 1. Okay, next what we'll do here is, they have in the problem they told us to consider C and D as select lines. So C and D are select lines. So what we'll do here, now this is 0, CD is 0 0 0 0 means this is for input I naught, and then 0 0 is input I naught, and then 0 0 means input I naught, and then we have 0 0 is input I naught. Okay, so for the input I naught we will form a truth table with A and B as inputs for to find the expression for I naught. A is equal to 0, B is equal to 0. So here A is equal to 0, B is equal to 0, F is 1. So therefore this is 1. Okay, and coming to this function, this I naught, this is 0 1. A is equal to 0, B equal to 1. A is equal to 0, B equal to 1, F is 0. And coming to the third I naught, this is 1 0. A is equal to 1, B is equal to 0. A is equal to 1, B is equal to 0. So therefore it is 0. I naught is 0. And the last Y naught, you can see here, both are 1 1. A equal to 1, B equal to 1. So your I naught is 1. So A equal to 1, B equal to 1. A equal to 1, B equal to 1. This is 1. This is for I naught. Now the expression for this one, is A B. The expression for this one is A bar B bar. Okay. Similarly, now next what we will do here is, this one CD is 0 1 I1. So next 0 1 is I1. Next 0 1 is I1. Next 0 1 is I1. So 4 I1s are there, 4 I0s are there, 4 I2s are there, 4 I3s are there. So after that we don't have. So next what we'll do here, we'll try to find what is for I0 expression A and B. So for I1, A equal to 0, B equal to 0, 1. A equal to 0, B equal to 0, 1. Next I1 here you consider So A equal to 0, B equal to A equal to 0, B equal to 1. So A equal to 0, so 1 second, sorry. So for this one, A equal to 0, B equal to 0, 1. So A equal to 0, B equal to 0, 1. And coming for next I1, this I1, A equal to 0, B equal to 1. A equal to 0, B equal to 1, this is 1. Coming for next I1, this I1, so A equal to 1, B equal to 0, it is 0. A equal to 1, B equal to 0. I have not entered here, sorry, 0, it is 0 here. And then coming to the last I1, so this is the last I1, 1, 1, it is 1. So for the I1, so A equal to 1, B equal to 1, it is 1. So these two we can combine, we can form, and this is simply nothing but A bar, and this is simply nothing but B. So A bar B. Expression for I1 is A bar B. Similarly, we can find for I2. For I2 it is A bar, it is A bar. This is I2, this is I2. Okay. And for I3 we find that it is A bar plus B. See here, for I1 A bar plus B, I3 is also A bar plus B, which is equal to I1. So I3 is equal to I1. So therefore option is B. So what are the expressions? So expressions are AB plus A bar B, AB plus A bar B bar, option B. So AB plus A bar B bar, and this one I1 is A bar plus B, I2 is equal to A bar, and I3 is equal to I1. So we can see here I3 is equal to I1, and you can see here I2 is equal to A bar. We'll move on to the next one. Ninth question. So they have given F. There are three variables A, B, C. F is a function of three variables A, B, C. So they have given a 2 cross 1 marks. 3 stages are there. We need to find out D0, D1, D2, D7. So D0, D1, D2 we have to find out. So we'll see here now. Ninth question. So ninth question, you can see here 3 stages have been given. So you can see here first you write down A, B, C. So all input combinations from 0, 0, 0, 0, 0, 1, 0, 1, 0, and last combination will be all ones. So for 3 input variables you will have 8 input possibilities, combinations are there, all 0 to all ones. This we already know. Now we'll try to write what is the F value for each input combinations. What is the F given? It is A plus BC. So now here A is equal to 0, B is equal to 0, therefore A equal to 0, B equal to 0, you will get here F equal to 0. Similarly for this combination, A is equal to 0, B equal to 0, A equal to 0, B equal to 0, you will get F equal to 0. Similarly for this combination, A is equal to 0 and B and C are 1, 1, this is 0, this is 1, therefore you will get 1. 0 plus 1 you will get 1. For remaining combinations 1, 1, 1, 1, A is 1, whether it is 1 or 0, A is always 1, therefore your outputs are 1, 1, 1, 1. And this becomes D0, this becomes D1, this becomes D2. So D0, D1, D2, first 3 zeros, remaining are 1s. Answer is option B. So option B, first 3 zeros, remaining are 1s. Option B. 10th question. It is about BCD to decimal decoder. That means 4 inputs, there are 10 outputs. D0 to D9. We have 10 outputs. Okay. So what we will try to do here is we will first have to find out the expression for Y0, Y1, Y2 and Y3. So we will first find out the expression for Y3. So Y3 is equal to D9, D8, D7, D6. So you can see here expression for Y3 D9, D8, D7, D6. So Y3 is equal to D9, D8, D7, D6. Similarly for Y2 it is D9, D8, D7, D6, D5, D4. For Y2, for Y2 it is D9, D8, D7, D6, D5, D4. Similarly for Y1 and Y2 we can find the expression from the figure. So once you find out the expression, now we'll consider the input combination x0, x1, x2, x3. So we'll start from 1, 2, 3, 4, 5. That means 0001 is 1, 0010 is 2, this is equivalent to 3, this is equivalent to 4, this is equivalent to 5, 6, 7, 8. Okay. So now for this input combination 0, 0, 0, x0 equal to 1, x1 equal to 0, x2 equal to 0, x3 equal to 0. So what is the output? What is the output we have to see. For this input combination, what will be selected here? So if this is 0, this is 0, 0, 0, 0, 0, 1. What will be selected here is D1 will be 1. D1 will be 1. Remaining D0, D2, D3, D4, D5, D6, D7, D8 all will be zeros. So for this input combination only D1 will be 1, remaining will be 0, 0, 0, 0. So therefore for Y0 this is 1, 0, 1 plus 0 plus 0 plus 0 plus 0. You will get here 0. For Y1 there is no D1 term. All the so we know that except D1 all the other inputs D2, D3, D4 all are 0, 0. So 0 plus 0 plus 0 plus 0 is 0. For Y2 there is no D1 term. So D4 is 0, D5 is 0, D6 is 0, D7 is 0, D8 is 0, D9 is 0. So therefore Y2 is also 0. For Y3 there is no D1 term. So that means remaining terms are this is 0, this is 0, this is 0, this is 0. So you will get Y3 is also equal to 0. So if we consider this one, that means input equal to output we got. Input equal to output we got here, which is equal to BCD1, which is equal to BCD1. Let us, for this input combination we will get the same input equal to output, which is equal to 2. For this input combination we will get the same, which is nothing but 3. For this input combination we will get 4, which is both are same. For 5 also both are same. For 6, so for 6 what we will get by substituting this, we will get as 1, 1, 0, 0. So if you try to convert this into a 2421 code, so what we will get is, so this is for this we are trying to find output for 6. So Y3 is 6, this is 2, see here, this is 1 and this is 1, this is 1 and this is 1. So 2 plus 4 is 6, remaining is 0, 0. 2 plus 4 is 6, therefore we got is 6. So that means so for the remaining input combinations, if you try to find the output, for example for 7, so what we get here is applying the formula here. So Y0 will be 1 and Y1 will be 0, Y2 will be 1, Y3 will be 1. So this is 1, this is 1, this is 1. So that means 2 plus 4 plus 1. 2 plus 4 is 6, 6 plus 1 is 7. I got it 7. That means this is a 2421 BCD code. The answer is option B. The answer is option B. 2421 BCD number. So coming to the 11th one. So 11th one, an even parity checker indicates a parity error for which of the following received data and parity bit. Choose the correct option. So the even parity checker indicates parity error. Let us consider the answer first. For option C, 2 and 4. In both cases, the number of ones is odd, including parity bit. Parity bit can be either 0 or 1. So we will see now 2 and 4. For the 2 here, so the number of ones is odd because number of ones is 3 here, including parity. Whether parity is, so including parity, therefore this is an odd parity. Therefore you will get an error. Parity error will be there for 2. For 4, so including all entire thing, there are 8 bits. So 1, 2, 3, 4, 5, 6, 7 zeros, 1 parity bit, totally 8. So out of 8, so one is there. So therefore the total number of ones in the transmitted bit or received bit will be odd number. It is an odd number. Therefore for 1 also we will get a parity error. For the remaining, if you can see here, this is total number of ones is 8. 8 is even number, and in this case total number of ones is 3 plus 1 is 4 even number. In this case 5 plus 1 is 6 even number. In this case 6 plus 0 6 even numbers are there. Therefore there is no parity error. So the answer is C, option C. Option C, 2 and 4. Option C, 2 and 4. 12th question. This is a 8x3 priority encoder. We will see the solution for this one. So priority encoder. So 12th one, priority encoder. So 8 inputs are there: D7, D6, D5, D4, D3, D2, D1, D0. D0 is LSB and D7 is MSB, and D7 is highest priority and D0 is lowest priority. So we will start from first D7. If D7 is 1, what will happen the output? So whatever may be the other inputs, whether it is 0 or 1, so your output will be always 1, 1, 1, which is equal to decimal 7. This is equal to decimal 7. Next, you consider if this is 0 and this is 1, because D6 is having the highest priority among the other inputs. So therefore whatever may be the other inputs, this is having the highest priority because this is already 0. So therefore what you will get is 1, 1, 0, which is equal to 6. So next will get 5. It will be 4. This is 3. This is 2. This is 1. This is 0. So 0, 0, 0, 0, 0, 0, 0, 1. So we are writing the binary number in the reverse order. 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. So how we are writing here? This number is 7, write 7. This number is 6, write 6. If this number is 5, write 5. That means 1. So for example D1 is 1 here, this is 1 here, 0, 0, 1. For example D2, this is 2, this 2 is 1 here, this 1 here. So I have to write 2, I have to write here 2, that 2 is 0, 1, 0, 0, 1, 0. So you simply write the binary equivalent of the subscript of datas if it is 1, okay. And then what we'll do here is by, let us try to find for Q2. For Q2, so from the observation of the table, so what we find here is, from the table what we find for Q2 is, so from the observation D4 plus D5 plus D6 plus D7, okay. So we will see the answer here. So Q2, so Q2, D4, D5, D6, D7, option B. Similarly for option C, D4, D5, D6, D7. So what we find here is only B and C has Q2, D4, D5, D6 and D7. So our choice is, we need to select either B or C as the right answer. And one more thing, for B and C, Q1 expression is same. Q1. So what is Q1 here? For B, Q1 expression is D5, D4. So for C also D5, D4. Here is D2 plus D3. Here also D2 plus D3. It is D6 plus D7. D6 plus D7. So for B and C, Q1 are same. Expressions are same. Now for trial and error, we use trial and error method to find which is correct, B or C. So we try with B, option B, and we found it is correct. So how we found it is correct? So option B is correct. Okay. So option B is correct. So we know the expressions for Q0, Q1 and Q2, Q1 and Q0. So we will try an error method. So what is here? You apply for trial and error method. Okay. So we will get here for Q2 we will get 0 here, for 0 0 that means D4 equal to 0, D5 equal to 0, D6 equal to 0, D7 equal to 0. Okay, and for those values, for both values we will get 0 1, and then we will get Q0 is equal to 1. I done some simply worked out here. Okay, we found that option B is correct. Option B is correct. So option B is correct. Okay. Now 13th one. So they are given a circuit here. This is a DMUX, one input, 3 select lines, and I0. This is bubble I2. This is I2 bar. Okay, and this is I5, I6, I7. So how many terms are there? 1, 2, 3. So variables. How many variables are there? We'll go here. A, B, C, D. Okay. So first, what we will do for the 13th question, for the okay 13th question. For 13th questions, this is the diagram they have given. So I0, I2, I5. These three are connected for F. Okay. Now what we'll do here? A, B, C are select lines. A, B, C. I have taken A, B, C, D. Okay. Now we'll try to find what is F. For A, B, C, D, we'll try to find what is F. Okay. Now what is F here? F is nothing but I0 plus I2 plus I5. Actually, this is the expression, because this is coming to OR gate, I0 plus I2 plus I5. Now the thing is, if A, B, C 0 0 0, because these are select lines, A, B, C are 0 0 0, then you can see what is D. If A, B, C are 0 0 0, that means what will happen? This I0 is connected to D0. So this D will I0 equal to D. I0 is equal to D. So I0 is equal to D. So what you will get here? If D is equal to 0, you will get I0 equal to 0. If D is equal to 1, we will get I0 equal to 1. So remaining is not connected. So therefore, for A, B, C 0 0 0, A, B, C 0 0 0, so your F will be 0 and 1. Okay. And next is for the combination. Next we will see here 0 1 0, 0 1 0. So 0 1 0, 0 1 0. Okay. So what will be connected? So why have taken 0 1 0? Why have taken 0 1 0, 0 1 0? Why? Because I2, for I2 input combination will be 0 1 0. For I2 input combination is 0 1 0. Okay. Now what about data D? Here you can see here I2, this I2. So now remember, if this is 0, your I2 will be 1, and if this is 1, your I2 will be 0. Why? Because I2 is complemented. Followed. So therefore, what we get here now? F equal to, so F is simply nothing but I2. I2 is 1 here, F is 1 here. I2 equal to 0 here, F is equal to 0 here. So coming to the last combination, this is for I5. So I5 means 1 0 1. So 1 0 1. Again D has two possibilities. 0 or 1. So next what we'll do here? So only I5. So these two are don't care. No, not connected. So here I5 is equal to this one, D. I5 is equal to D. So if this is 0, this will be 0. If this is 1, this will be 1, because there is no complement here. I5 is directly connected. Here there is a complement. So therefore, I0 and I5 are same. Okay, because I0 and I5 are same. Only I2 is having complement output. 0 here, 0 here. 1 here, 1 here. Now therefore, F is equal to, because this is 0, F is 0. Because I5 is 1, F is 1. So we got all F's now. We have to identify. This is for I0, this is for I2, this is for I5. Okay. So the input combinations is 0 0, 0 0 0, 3 zeros, 3 zeros. Okay, we know, just now we discuss now. And now forget about I naught, I2 and I5 now. I already discussed it. We need to identify. So why I identified this one? So expression. So in this, what is the output? Output is 1, output is 1, output is 1. So we have to identify the input combinations for which F is 1. F is 1, this combination. F is 1, this combination. F is 1, this combination. So what is this one? 0001 is, so 0001 is 1, 0100 is 4, and then 0111 is 11. So 1411, 1411. Option C. Option C. Next one, 14th. So 14th one. So what is there is decoder 1, decoder 2 is given. So PQ, PQ, two input variables, only two input variables, PQ and PQ. So what we'll do here for the next question? For the next question, first consider P and Q, write all the input combinations 0, 0, 0, 1, 1, 0, 1, 1, that's all. And we'll see here in the diagram here, and this is I naught, this is I1. So we need to write what is I naught and what is I1. I naught is PQ, I1 is P bar plus Q. Okay. So therefore, what will happen? I naught is PQ. So P and Q are 0, 0. This is 0. And P and Q are, P is equal to 0, PQ. 0 multiplied by 1 is 0. 1 multiplied by 0 is 0. 1 multiplied by 1 is 1. Similarly, we can write for I1. This is I1. I1 here, I1. So I1, for I1 it is P bar plus Q. So for I1, for example, P bar is P equal to 0 means P bar becomes 1 and it is 0. 1 plus 0. 1 plus 0 is 1. For this case, P bar is equal to 0 and Q equal to 1, therefore 1. Okay, once you have written I0 and I1, once we have found out I0 and I1, so based upon these combinations, based upon the input combinations, so this will be selected. So either D0 will be 1, D1 will be 1, D2 will be 1, or D3 will be 1. So we'll see here. So for 0, 1, D0, for 0, 1, for 0, 1, for 0, 1, for 0, 1, D1 will be 1, D1 will be 1, D0 and D2 are 0, 0. So 0, 0. For these two combinations, 0, 0, 0, 0. What about now 0, 0? For 0, 0, if it is 0 and this is 0, what will happen? D0. So D0 will be 1. D0 will be 1. All others are 0, 0, 0. So we are talking about D0. So D0 will be 1. For 0, 0, D0 will be 1. Once again you see here. If this is 0, this is 0, D0 will be 1. Remaining will be 1, 1 and 1. Sorry. For 0, 0, D0 will be 1. D1, D2, D3 are 0, 0, 0. So therefore we are considering only D0. We are considering only D0. So D2 for this combination, D0 is equal to 1 and D2 is equal to 0. Next, for 1, 1 combination, for 1, 1, if I0 equal to 1, I1 equal to 1, D3 is selected. I mean D3, you will get D3 equal to 1. All others are 0. All others are 0. Therefore, D0 equal to 0, D2 equal to 0. So D0 equal to 0, D2 equal to 0. Okay. Next, we will try to find what is Y1. What is Y1? Y1 is D0 plus D2. What is Y1? So Y1 is D0 plus D1. Okay, OR get. So 0, 0, 0, 0, 0, 1. 1 plus 0 is 1. 0 plus 0 is 0. Now what is P? So we know P. This 0 here, 0 here. 0 here, 0 here. 1, 1, 1, 1. So now these two are the inputs to the next. So here we can see here P and y1. Now we'll see the combinations. If both are 0 0, what is the output? Output. So output here. So output is simply nothing but y2 is nothing but d5 and d7 multiplication. It is an AND operation of d5 and d7. So d5 d7. Okay. d5 d7. So if this is 0, this is 0, this is 0, this is 0. So d4 will be 1. Remember, this is complement here. It is now complement. d4 will be 1. Remaining will be 0, 0 and 0. So d5 will be 0, d7 will be 0. Your output y2 will be 0. So it is what we done now. Y 0 0 0 0. 1 second. We'll see 0 0. We written 1. So if this is 0, this is 0, we will get this as sorry. If this is 0, this is 0. If this is 0, this is 0, we will get this. This will be actually 1. All others are 0. No, sorry. 1 second. 1 second. Oh, correct. 1 second. If y10 y10 p0, that means I30 I20. These two inputs are 0 0. If these two inputs are 0 0, then of course we get d4. We get output at the d4, and that is, and here in this case it is 0. Remember, it is 0, and all others will be 1 1. All other d5 is 1, d6 is 1, d7 is 1. So you can see here d5 is 1, d7 is 1. Therefore output is 1. And similarly for this one. In case for this combination 1 and 1, for this combination, this is 1, this is 1. What will happen? This will be 0. This will be 0. So if this is 0, output will be 0. So it will be 0. For this combination 0 1, for 0 1, this is 0, this is 1, and what we will get is d5. d5 will be 0 1. This is 1. Okay. So sorry, d5 will be 0. d5 will be 0. d7 will be 1. I mean, for see here, for 0 1, for 0 for 7 second, for 0 1, this is 0 and this is 1. So what will be select? d5. d5 will be 0. All others are 1. This is d4 equal to 1, d6 equal to 1, d7 equal to 1. Because d5 is equal to 0, your output equal to 0. So now if you compare output with p, this is 0, this is 1, this is 0, this is 1, this is 1, this is 0, this is 1, this is 0. So y equal to p bar. Option C. Last 15th one. So we have to implement NAND NOR XOR with two input mux. So I'll discuss for one. It's already late. NAND gate. It's a two input NAND gate, A and B, 0 0 0 1 1 0 1 1. 0 0 0 1 1 0 1 1. So for output for NAND gate is 1 1 1, and this is 0. Remember, this is for AND gate truth table. This is an AND gate truth table. For all the input combinations except 1 1, the output is 1 1 1, and this is 0. Now we'll for this particular, for A as a select line, 0 0, this is 1 1. So what is the I naught here? So I naught here, this is 1. Both are 1, therefore it is 1. For this particular, sorry, I naught. Okay. For I1, so what is there? This is 0, this is 1. This is 1, this is 0. Therefore I1 equal to B bar. So for this particular mux, for this particular NAND gate, first I will consider this mux y, and I naught I1. I naught is 1, therefore this is 1. I naught is equal to 1. I1 is B bar, so I1 is B bar. But how to obtain B bar? So to obtain B bar, we are using another mux, which is nothing but this will act as a NOT gate. So this is 1. I naught is equal to 1. I1 is equal to 0, and this is select line B. If B is equal to 0, we will get here 1. If B is equal to 1, we will get here 0. Therefore, your output will be B bar. Your output will be B bar. Therefore, 2 NAND gates are required. Similarly, for this expression, we have B bar. We have B bar and 0. So, you can see here this mux I not equal to I1. I made a mistake here. I1 equal to 0. I1 equal to 0 and I not equal to B bar. This should be connected here. This should be connected here. But the thing is, we need again a 2 multiplexer. We need again a 2 multiplexer. And for this one, XOR gate, I not equal to B, I1 equal to B bar. So see here, I not equal to B, I not equal to B, I1 equal to B bar, I1 equal to B bar. So how to generate B bar? So we have to generate B bar using another mux. For all these 3, we have NOT gate, and NOT gate, which is B bar, and B bar. B bar is required for all the 3 gates. So therefore, option C, 2, 2, 2, 2. Thank you, viewers.